Hello students, in the series of learning C++, today we are going to study about pointers and functions. So our today's objective is we will have introduction about pointers, basic concepts, address versus value and value versus location. We will understand dereference and reference operator, functions. Then we will understand user defined function, function components, argument passing, and at last we conclude everything in a summary. So let's start with the basic element of C++. What happens when once a program is compiled? Fine. So a typical memory representation of a C++ program or in C program also consists of these following four sections. Basically, they are code area, stack area, data area, and heap area. This code area is also known as text area or text segment. This area is mainly used to hold the compiled program code. And this text area is one of the section of a program in an object file or in memory which contain executable instruction. See, as a memory reason, a text segment may be placed below the heap or below the stack in order to prevent heap and stack overflow from overwriting. I'll tell you about stack and heap also, but do remember this text area we will always place below the heap and stack area so that there is no overflow. And because of that overflow, there is no overwriting in this text area. Fine. So usually a text segment is a shareable so that only a single copy needs to be in the memory for frequently executed program such as text editor or the C compiler or the shells, and there are many more. Also, the text segment is often read only. Fine, the access right is read only. We won't be able to do modification in that text area. This is because it want to prevent the program from accidental modifying its instruction. In case any key will be pressed and any default value will be set or any wrong value will be set, then it can create problem in program compilation. So basically the access right for this area is read only. Fine. Now next area is stack. As we all know that stack is the data structure that works on LIFO order. LIFO is last in and first out order. So area that hold the return address of a function call, argument passed to the function, local variable for function, and the current state of CPU. See, we are using so many functions in our program because we know that function is a self-contained block of statement that we are designing to do any specific task, so that we need not to create that particular section again and again, and whenever we need that particular task to be done, we simply call the function. Now for that thing, that function requires some definition, function requires some calling. So for all those things, function needs to maintain a reference point. Now for that thing we are using this stack area, plus which argument we will pass, local argument, formal argument. So all those things are handled by stack area. Then also local variable for the function. See, we are having two types of variable, global variable and local variable. Local variables are those variable which are specified inside some function only. As soon as that function brace is open and we declare a variable, its life start, and as soon as we close the braces, that life of that particular variable will be destroyed. So for those local variables also we need stack area to maintain. Then for current state of the CPU, whether your CPU is in waiting state, ready state, means all these state are also maintained by stack area. So stack, where automatic variables are stored along with the information that is saved each time a function is called. Fine. Then we have a data area. Data area or data segment is mainly used to hold global variables. So I told you about local variables. Now global variables are those variables which are defined before main function or before any function, so that we can use that particular variable throughout the program. Because as soon as, if it is a local variable, means if it is inside some function, as soon as your programming your function braces is closed, that scope and life of that function or that variable will be destroyed. So whenever we need a variable that we need throughout our program, we define that variable as global. So for that thing we are using data area. Fine. There is one more concept. This data area also include static variable. As soon as we will proceed in C++, you will learn about static variable also. For now, do remember, data area holds both global variable and static variables. Fine. Then heap. Heap is an area from which memory is dynamically allocated to the program. We know that we are having two types of memory allocation: static memory allocation and dynamic memory allocation. So static memory allocation is a memory allocation where we allocate the memory at compile time. Now in that case there is so much wastage of memory, because in the starting of any program, not even a single programmer can predict what size of array he need, what exactly, how many number of variables he need. So ultimately we go for maximum sizes, and if that maximum size is not completely occupied, that means throughout the time it is complete wastage of memory. That's why we need dynamic memory allocation, where we can do memory allocation at runtime. So according to our need, whenever it is required, we will allocate the variable, and whenever that variable is not no longer require, we can free that memory. So for that thing we use heap area. So these are the four distinct region of memory: code area, stack area, data area, and heap area. Fine. Now let's start with addresses. See, we all know that memory of our computer can be imagined as a succession of memory cell, and each one of the minimal size of that computer manage that minimal size is 1 byte, right? So these single bytes memory cells are numbered in a consecutive way, so as within any block of memory, every cell has a number as a previous one plus one, right? So this way each cell can be easily located in memory because it has a unique address, and all the memory cell follow a successive pattern. For example, if I want to locate any memory cell, let us suppose I want to locate 1776th memory cell. Fine. So I'm pretty sure I'm going to find this memory cell to the right between 1775 and 1777. Fine. There only I will find 1776. I'm so sure about it. And we also know that it is going to be exactly 1000 cell after 776, right? When we add 1000 in 776, then only we will reach to 1776, right? And exactly 1000 cell before 2776. So this is how we can easily predict the memory location and where particularly we will find that particular item, right? So every byte in memory has an address. This address is positive integer number starting from 0 and go up from 1, 2, 3 and so on. Let us suppose if I am having a memory of 640 KB, right? So we know that 1 KB is equals to 1024 bytes, right? So 640 KB is equals to 640 into 1024 bytes, correct? So how many bytes we will have? We will have um, 65536 bytes. Fine. So this 65536 bytes of memory, then let us suppose our first address starts from 0. Second address will be at 1. Third address will be at 2. Fine. Correct. So my last address will be 65535 because it is starting from 0. Correct. So this is how memory address help us to find out any particular variable in the memory. So computer's memory is organized as a linear collection of bytes. Every byte in computer's memory has an address. Each variable in program is stored at a unique address. This is very essential in case of addresses. We can't afford ambiguity in addresses. See, it is almost similar to our real world. Like, consider this full world. If we don't have any address, then how we can locate any person? It is very hard to locate anyone in this complete world, correct? And what happened now? We are having addresses. So whenever I want to go to someone, I will have a reference point that this point, if I reach to this address, I can locate this person. Fine. Similarly, in memory also, we are having addresses to locate variables and the value inside those variables. Fine. So we can use a address operator. Address operator means this %. If you can see, this %, will be known as address operator from now onwards. This %, address operator, we will call it as address of. Whenever I have this %, I'll call it address of. So we can use this address of operator to get address of a variable. Fine. Let's take an example. I'm initializing a variable. So I'm writing return type, variable name, and I'm using assignment operator and I'm assigning some value. Fine. So return type is integer, as you can see, int. My variable name is num. And using assignment operator means this is my assignment operator. Using this assignment operator, I'm assigning 23 to num. Fine. Now, if I want to get the value 23, what I have to do? I have to write cout num. Fine, we know this thing. Whenever we want to print the value, we have to write cout and we have to write variable name. Correct? Now, I want address of this 23, where this 23 is exactly located. So for that thing, what I have to do? I have to use this % operator. So I will write cout address of num. So by doing this thing, it will print me some hexadecimal value, that is address of this variable num. Correct? Let's start with pointers. A pointer is a variable that represents the location rather than the value of a data item. We know that pointer is a variable that holds the address of another variable. Location is nothing but address of another variable. So whenever we need to refer the address instead of value, we use pointer. Fine. They have a number of application. First application is enable us to access a variable that is defined outside a function. See, as I told you about local variables and global variable, if some variable which is defined inside a function, it will be a local variable, and scope of that variable is inside that function only. If we have a variable that is located outside the function, then to refer that particular variable, we will deal with address, and for dealing with the address we need pointers. It reduces the length and complexity of a program, sometimes also increases the execution speed of a program. Pointers can increase the execution speed also. Then it can be used to pass information back and forth between a function and its reference point. We all know that we are using function so that our coding will be easy. We need not to type again and again, and we don't want to waste our so much time. That's why we are using function. So whenever we want to repeat something, or whenever I need to execute the definition of function, I have to call the function, right? This thing we already studied in function chapter in our C programming. So if you are not knowing concept of function, please refer function once. So function we have to create a reference point. If we whenever we call a function, or whenever that function will return, it need a reference point. So for that thing also, our pointer will play a major role. It is very efficient in handling data tables. Now data tables, for each and every variable, our compiler create a data table. For maintaining symbols, it will create a symbol table. For that purpose also, for efficient use of data table also, we need pointers. So these are some application of pointers. Basic concepts about pointer. See, C++ uses pointers explicitly with arrays, structures, and function. We know that these three are the major portion of C and C++. Uh, Structures, arrays collection of so many data types. Array is collection of similar data type, but we can have uh, large size also. Size will depend on us which size array we need. Structured is a user defined data type that contain so many data types. Fine. So for structure also, and for function is a self-contained block of statement which is specifically designed to do any particular task. Now in the major components, in the major concepts of C++, we are using pointers. So in memory, every stored data item occupies one or more contiguous memory cells, right? We know that our memory is made up of bytes, and every cell in that memory have a address, correct? So for memory management also, we are using pointer. So the number of memory cell required to store a data item depends on its type. We have data types in C++ means in our coding we have data type. So each and every data type reserved some bytes of memory. Like for example, a character can hold 1 byte, integer can hold 2 bytes, double can hold 4 bytes, like this. Fine. So if I declare a variable of integer type, so how I can declare a variable of integer type? Int a. Fine. So if my compiler execute this statement, compiler will reserve 2 bytes for the variable a. If I declare something of character type, let us suppose chars, then my compiler will reserve only 1 byte for that particular variable s. So the number of memory cell required to store a data item depends on the data type. Fine. Whenever we declare a variable, the system allocate memory location to hold the value of the variable. Now, if I'm declaring int a, then that int a is a variable of integer type, and it will reserve 2 byte in memory, so that whenever I put any value, I assign any value to a. Let us suppose I do a is equals to 10. So using assignment operator, if I am assigning any value to the variable a, that value will be stored at that memory location which is reserved because of its size. Fine. Since Every byte in memory has a unique address. That's why we won't be able to tolerate this ambiguity in this address. This location will also have a unique address. Its own unique address will be there for each and every variable. Now, consider this statement. If I'm defining a variable marks, for defining a variable marks, I have to write return type. My return type is integer. Marks is a variable name. And using assignment operator, I am assigning 22 marks. Fine. So, because of this statement, compiler will allocate location for a integer variable marks. Compiler will reserve 2 bytes for this integer variable marks and put the value 20 in this location. Fine. Now, marks is my variable of integer type. 20, because I assigned value 20 to marks, 20 is my value. And let us suppose the address location chosen is 1039 for this variable marks. So address is 1039, value is 20, and my variable name is marks. Fine. Now, since memory address are simply number, they can be assigned to some variable which can stored in memory. They are simply numbers. Memory address, like I'm saying, it will start from 0 to so on, from depends on the size, how many bytes, how many KB, how many MB memory you are using. So depending on that size, it will be number. So we can use these addresses as value to some another variable. Fine. Such variable that hold the address, they are known as pointer. So pointer is a variable which is going to hold memory address of some other variable. Fine. Since pointer is a variable, its value is also stored in some memory location. Every variable will have an address. Every variable, if you assign value, will have a value. And that value will be stored to some memory location. And pointer is a variable whose value is address of some another variable. Then also that pointer variable will be stored at some memory location. Fine. So let's clear this thing with the help of this example. If I'm assigning a variable marks of integer type with value 20, I have to write int marks is equals to 20. Fine. Let us suppose I have a variable that is p. Now what I have to do for assigning address of marks to p? We know that we have an operator, address of operator. Address of operator is used to assign the address of any variable to another variable. It is also known as a reference operator. The address that locates a variable within memory is what we call a reference to that variable, right? So if I write p is equals to address of marks, the address, whatever address, let us suppose address for this marks is 1039. So this 1039 will be allocated as a value to p. So now after this statement, 1039, which was address of marks, will be value for this variable p. Fine. So we are having two variable marks and p. Value for marks is 20 and value for p is 1039. Let us suppose address for marks is 1039, then address of p is 2255. Fine. So I hope this thing is clear to you. Now let's clear that thing with the help of some proper diagrams also. Address versus value and value versus location. Each and every memory cell has an address associated with it. Each cell also stores some value. Fine. Don't confuse the address referring to a memory location with a value stored in that location. See, let us suppose I am having these cells. Fine. Address for these cells are 101, 102, 103, 104, 105, 106, 107 and so on. Now, as you can see, whatever we put inside this cell will become its value. As you can see right now, 101 is not having any value. 102 is also not having any value. But 103 memory location is having 3 as value. Correct? 104, 5 and 6 are also empty, but 107th memory location is having 66 as value. So all these 101, 102 are address. 366, these things are value stored on that particular memory address. Fine. Value versus location. Now, variable name, memory locations which hold value is our location. Like this is, let us suppose this as a memory cell. Fine. This x, if I define int x, my compiler will give 2 bytes for this x. So this is, let us suppose this is my 2-byte memory cell and this x is my variable name. Fine. If I write x is equals to 33, then this 33 will become value for this x. Fine. And this will have some memory location. Let us suppose 1024 is memory location or address of this particular x. So 1024 is my address, 33 is my value and x is name of my variable. Let's start with pointers. Pointer is just a C variable whose value is the address of another variable. So pointer is nothing but a variable. We will define it as a variable only, and only difference between a normal variable and a pointer variable is that normal variable only holds value, but the value for this pointer variable is address of some another variable. Fine. So syntax for declaring a pointer variable is we have to write data type. Then we have to put this star. This star is known as dereference operator. This pointers star are set to point to the variable whose reference they store. Fine. So basically this star which act as a dereference operator and that can be uh, translated to value pointed by. So I'm defining a pointer variable. I'm writing data type that is integer. I'm putting dereference operator star and I'm writing name. Name is this pointer variable name. So let us suppose I'm giving a name ptr. Fine. So now my pointer variable is ready. Pointer variable right now, pointer variable is not pointing to anyone because it is not having any value. Fine. This is a normal empty pointer variable right now. It is an integer pointer variable that can hold the address of some integer variable. Fine. If we have a character pointer variable, it can hold value of some character pointer means character variable location. Fine. So it depends on data type. According to the type of pointer variable, it will hold the value for no variable. So it is an integer pointer variable, so I am creating an integer variable. So for creating a normal integer variable, I have to write int and data type and variable name. So I'm writing int and num is my variable name. Now if I assign address, because I know that pointer variable holds the address of another variable. Now how I can supply address of variable num to pointer? I have to use address of operator. So for that I'm writing ptr is equals to address of num. So whatever address this num will have will become value to pointer variable ptr. Fine. So I hope declaration of pointer variable is clear. We have to write data type. asterisk mark. This asterisk mark is nothing but a dereference operator, and then we have to write variable name, any variable name of your choice. You can write any variable name. So we can declare int star iptr or int star ptr, float star ptr, then character star ptr. So all will become character, float and integer pointer. Fine. Now let's start with dereference operator. Now using pointer we can directly access the value stored in a variable which it points to. So for that thing we need a dereference operator. To do this we simply have to precede the pointer's identifier with the asterisk, which acts as a dereference operator, and that will be translated as value pointed by. So after declaring if int star ptr, I will call it is an integer type pointer which is going to point some integer type variable. So ptr does not actually points to anything yet. We can either make it point to something that already exists or allocate room in memory for something that new means something new that will point to. So it can point already existed variable also, or if you create a new variable also, then also you can make it to point that particular variable. Just by defining int star ptr, that time it will not point anything. That time it will be a normal pointer variable. You have to make it point to something. Fine. So that we can do by providing address. Fine. Next is reference operator or address of operator. The address that locates a variable within memory is what we call a reference operator. So we know that as soon as we declare a variable, the amount of memory needed is assigned it as a specific memory location. That is its memory address. We generally do not actively decide that exact location of variable within the panel of cell that we have imagined the memory to be. Fortunately, that is a task automatically performed by our operating system during runtime. However, in some cases, we may be interested in knowing the address where our variable is being stored during runtime in order to operate with relative position to it. So for that thing, we are using reference of operator. The reference to a variable can be obtained by preceding the identifier of a variable with an ampersand sign. Fine. So this is known as reference operator, or we can call it as address of. It can be translated as address of. So if I'm declaring a pointer variable, if you can see, it is a pointer variable, return type star ptr. It is not a normal variable, it is a pointer variable, means it will going to hold address of some other variable. Which type? Integer type, because this pointer variable is of integer type. Now I'm creating a normal variable, so I'm writing int var. This is a normal variable. Now after doing this, we are having a variable. Right now we don't have any value inside. We are having a var normal variable and a ptr pointer variable. If I assign var is equals to 32, then this value will go to var variable. Fine. So this time if I assign var is equals to 32, after that time this var will have a value 32, and let us suppose address location for this var is 1024. Now we want to make that pointer variable to point var. Now for that what I have to do? I have to write ptr is equals to address of var. So address of var means I have to write ampersand and var, and I have to terminate this statement. So address of var was 1024 will become value for this ptr, that is this pointer variable is now holding the address of another integer variable, that is var. So this is how reference and dereference operator works. Now let's see this program with the help of a practical example. Let's implement this program so that we can understand this thing better. Fine. Okay. First of all, I'm including my header files. iostream.h, that is input output stream.h, because I want to use cin and cout. Then I'm including conio.h, that is console input output.h. I'm writing my main function. Now, inside this main function, let us suppose I'm having two values. Let us suppose one is my first value and one is my s means second value. Fine. I'm having two variables, f value and s value. Fine. I'm creating two integer pointer also. So I have to write return type. I have to write dereference operator, and I have to write variable name. So let us suppose my first pointer variable is p1 and my second pointer variable is p2. Fine. You can do like this, or you can put a comma and you can write like this also. So these are my two pointer variable p1 and p2. So whatever you want to use, you can use. Fine. Now, if I assign p1 is equals to address of f value. Now, by doing this, what I'm doing, I'm assigning the address of variable f value to p1. As you can see that, right? Now, I'm assigning address of second value to p2. So for that, I have to write address of s value. Fine. So by using this statement, address of first value will be allocated to p1 and address of second value will be allocated to p2. Fine. Now, if I now do f value is equals to 20 and s value is equals to 10. Fine. Now using pointer variable, I will print this thing. Fine. If I do cout f value, then I will get 20. If I do cout s value, then I will get 10. But I want to do this thing with the help of pointer variables. Fine. So I will do cout. I will use star value pointed by p1. I want that value which is pointed by p1. Which value is pointed by p1? p1 is having address of f value. That means address of f value means value pointed by p1 is 20 and cout value pointed by p2. So I will get that thing with the help of star p2. Fine. I'm putting get ch. Let's execute this program and let's check there is any error or not. Fine. Before that, I want to put CLR SCR in a program. So this is a clear screen function. Fine. Let's save our program. I'm saving this program as demo.cpp. Alt F9. Let's check for error. We don't have any error in this program. Let's run this program. Control F9. So as you can see, we are having 20 and 10. Let's put a endl so that we can get value properly. Or let's get a message also. First value is fine. And for this, let's have a message. Second value is fine. Now let's run it again. So as you can see, first value is 20 and second value is 10 because my pointer variable is pointing to f value. P1 is pointing to f value and P2 is pointing to s value, and we are printing that value by using pointer variable, that is value pointed by P1 and value pointed by P2. Fine. Now, what if I want to see address of this P1 and P2? What I have to do? I have to write cout address of, let us suppose I want to see address of f value. Fine. So address of first value address of first value means my f value variable's address. For getting address, what I have to do? For getting address, either I have to write address of f value, or I can simply write P1 also, because P1 is also having same thing, right? P1 is also having address of, you can see here, P1 is also having address of f value. So first address of first variable we are getting with the help of P1. Fine. Now for second variable, let's use address of operator. So cout address of second value, or better use second variable, let's print this thing with the help of address of operator, and let's print s value. So it will give us address of s value. Fine. Let's run this program. So as you can see, my first value is 20, my second value is 10, address of first variable is 0x8f86ff4, and address of second variable is 0x8f86ff2. Fine. You can see this is integer variable, so 2 byte difference. Fine. Let's put a endl here also so that you can get proper result. You can see proper result. Now I think you can understand 2 byte difference for first variable address and second variable address, because both are of integer type, and First value is 20 and second value is 10. Fine. Now, this is how we can get addresses of any variable. Now, if you want to see address of P1 and P2, because they are also pointer variable, but it's a variable, they will also have some address. So for that, I have to write address of pointer variable P1. If I want to see address of pointer variable P1, I will write address of P1. Fine. Let's put a handle here also. Address of pointer variable P2. So for seeing address of pointer variable P1 and P2, we are using address of operator. So this is my address of P2. Fine. Let's run this program. So as you can see, this is first value, second value, address of first variable, address of second variable, and address of pointer variable P1. So address of pointer variable P1 is and means 0x8 8f 8b triple f 0. Then for P2 we are having different memory address. Fine. So this is how you can find out the addresses and values of any variable. Next, let's start with functions. A function is a group of statements that together perform a task. We know that we are creating function so that we need not to write those particular group of statement again and again. We are defining a function so that only once we will define that particular function, and that task, whenever I want to execute that particular task, I can simply call that function. So for every C++ program has at least one function, which is main function. In every C and C program, our program execution start with a main function only. So if there is not any other function, there will be one function should be always there, that is main function. So and all the most trivial program can define additional function. In case you want to define any additional function, you can define. Fine. Now, basically we are having two types of function, library function and user defined function. Library functions are those functions which are inbuilt and are known as library function. These are also known as standard library function. They are already defined in system library of C++ compiler. Library function are also known as predefined functions. So basically, to use library function in a programmer need to include a particular header file related to that library function. For example, if we want any string function such as strlen, strcpy or strcmp, then we have to include string.h header file. User defined function are those functions whose definition are defined by the user itself, and it can be called in main function or any other user defined function also. just make a note that main function is not a library function. It is simply a restriction from C++ compiler that we have to use this function in our programming, as execution starts from the main function only. So that's why we use main function in our program. Fine. For user defined function, we have to declare a function first. Means we have to do prototype of that function. Prototype of or a declaration of a function tells that compiler that this function will be used in a program, just like we declare a normal variable before its use. It is compulsory to declare a function before its use. Then after declaration, we will provide definition that have actual body of the function, and then accordingly whenever we need, we can call that function. In C++, standard library provides numerous built-in functions that your program can call. For example, strcat is used to concatenate two string. Function memcpy is used to copy one memory location to another memory location. Like this, there are so many inbuilt function which help us to do all these tasks very easily. A function is known as with various name like method or subroutine or a procedure also. We can call a function as a method, we can call a function like subroutine, and we can call it procedure also. It depends on you what you want to call a function. First, defining a function or giving prototype of a function. As I told you that declaration is very essential. It is similar like we declare variable before we use that variable. Similarly, whenever you want to use any function, you have to declare that function. For declaring any function, we have a syntax. We have to write return type of that function. If the function will not return anything, we will write void. Fine. If the function will return, we have to write that it is returning some integer value or it is returning some float value. So accordingly we have to decide and we have to write return type. Then we have to write function name, and in bracket we write parameter list. So what parameters are going to, or what arguments this function is going to use. We can call any function. It also takes some variable or constant value. uh, so we will declare those parameter list here. Then the function body will open, and inside that we can write about function definition. So function definition, inside function definition, whatever uh, this block of statements surrounded by this braces, uh, that means all the statements are defined and execute when you call this function. So whenever you make define a function and you will open this braces and you will close this braces, whenever there is a function call, everything which is written inside this function braces, that is body of the function, will be executed. Function components. A C++ function definition consists of a function header and a function body. Here are all the parts of the function. First of all, return type. So a function may return a value. A return value is a data type of the value the function returns. Some function perform desired operation without returning any value. In such cases, we have to return void as a keyword. That void keyword means this function is not having any return type. That means this function is not going to return anything. But if some function is having return type, then that function have to return some value. If there is nothing to return for that function have to return 0. if that function is having a return type and it is not returning, it is essential to return 0. Fine. Then we have function name. This is the actual name of the function. The function name is and the parameter list together constitute the function signature. When you write a return type, you give a function name and you put those brackets, and in those brackets you write some parameter list, or if you don't write parameter list also, still that bracket should be there. That is the constitute signature for that function. Then parameter. A parameter is like a placeholder. When a function is invoked, you pass a value to the parameter. This value is referred to as actual parameter or argument. The parameter list refer to the type, order, and the number of parameter of a function. A parameter are optional, that is, a function may contain no parameter. Basically, your parameter or argument is a placeholder which we are using for the function. If that any value, any piece of data, if we want to pass into a function, we need this parameter. Basically, we are having two types of parameter: formal parameter and actual parameter. Formal parameter are the parameter declared in the bracket in function definition after the function name. That is our formal parameter. They are also called as dummy argument or parametric variables. Fine. Then we have actual parameters also. When any function being called from the main program and the parameter is used in the calling are called as actual parameter, which are individually declared in the main program itself. So those are actual parameter. These actual parameter are converted to formal parameter when the control goes to the function. It is to be noted that the type of formal argument declared used should also same as the actual argument. Means you can't change data type of actual argument and formal argument. It should be same. Fine. Then function body. Function body contains a collection of statements that define what the function does. So as soon as you define a function and you open the braces, whatever you write in between before closing the braces will become function body or function definition. Whenever that particular function will be called, that body should have to be executed. Function declaration. A function declaration tells a compiler about function name and how to call a function. The actual body of the function can be defined separately. A function declaration has the following parts. First of all, we have to write return type. We have to write function name. Fine. Then in bracket you can give parameter list. If that function includes some parameter, you have to write parameter list. If that function don't include parameter, you need not to write parameter list. For example, I'm creating a function max. That function max is of integer type. So I'm writing return type as int. Max is my function name. Now this max, let us suppose this function is finding out maximum between two numbers. So if it want to find maximum between two number, we need two numbers. That's why I am writing parameter integer number 1 and integer number 2. That is int number 1 and int num2. A parameter name are not important in function declaration, only the type is required. So if you write int max, int also, it is correct. Fine. The function declaration is required when we define a function in one source file and you call the function in another file. In such cases, you should declare the function at the top of the calling function. Fine. Pass by reference. When passing arguments by value, the only way to return a value back to the caller is via the function return value, because this is why we are using a return type, right? Because whenever we want to return anything, we use a return value. While this is suitable in many cases, there are few cases where better options are available. One such case is writing a function that needs to modify the value of an array. Example, sorting of array. So in such cases, in this case, it is more efficient and more clear to have a function modify the actual array passed to it rather than trying to return something back to the caller. So for such cases, one way to allow function to modify the value argument by using pass by reference. Fine. Means instead of passing value, we will pass reference. Now I hope after pointer you understood what is reference. Reference is address, right? So in pass by reference, we declare a function parameter as reference rather than normal variable. Instead of taking normal variable, that function as a parameter will take a reference variable. Fine. So this is my function. This function will not return anything, so I'm writing void. This add one is my function name, and as you can see, this parameter list, it is only having one parameter, and that is also not a normal variable. It is an integer type reference variable. Fine. Now as you can see in the body of the function, y is equals to y plus 1. We are incrementing this y by 1. So when the function is called, y will become a reference to the argument. Since the reference to a variable is treated exactly the same as the variable itself, any changes we made in the reference are passed through the argument. Fine. Generally, a function call passes value to the function, but what we are doing, the function being called creates another set of variable and copies the value into them. Fine. In call by value, additional copy is created. Fine. The function does not have to access the actual variable. What it is doing, it is working on the duplicate copy in the memory. Fine. So that's why this mechanism is fine if the function does not need to alter the value of actual variable in calling program. But there are situations if we would like to change in at the time, means if we would like to change the value of a variable of calling program. Now for that thing we need a provision of reference. Fine. So in C++, to pass parameter to a function by reference, when we pass argument by reference, the formal argument in a function become alias to the actual argument. It is similar like we have a school name and we have a nickname. So it become an alias. Fine. We will work on the actual copy of the data. We will not work on the formal copy of data. Fine. So for that thing, we have to pass the reference. For that thing, in the function parameter list, we will have a reference variable. For example, just have a look on this normal logic, then we will create a program also. We are creating a function void fun. So this is a function name. This is a function because it is having this bracket. This function is not returning anything, that's why it is not having any return type, so return type is void. Now this function takes a reference. Fine. So it is having a variable that is y of integer type. Now let's start with main function. As soon as our compilation start, our compiler go to main function. Here I am having a normal int x variable and value for that x variable is 5. Means this int x is a variable of integer type, x is a variable for integer type with value 5. If I do cout and I print value of x, it will print x is equals to 5, right? Now what I'm doing, I'm calling function fun and I'm passing x as argument. If I'm passing x as argument, value for x is 5. This y become alias for this x, means this y is now also having a value 5, correct? So if now I print cout y is equals to, I get 5. Fine. So I'm having cout x is equals to 5, cout y is equals to 5. Now I'm overwriting the value. I'm assigning y is equals to 6 and y is nothing but alias of x. So now x has also become 6, correct? So if I do cout y, the value of y will be 6 now because we changed value. So value will be 6, and after, as soon as this program is closed, this pointer will return to the next line of function call. Now my next line of function call is cout x is equals to, now x value, just because y was alias of x value is also changed and x value becomes 6. So your output will be 5566, right? So as you can see, output is 5566. So note that the value of x is changed by the function. Fine. Let's see another good example for call by reference. Let's make a program to swap two numbers with the help of call by reference. We will change the value of two numbers with the help of reference. So first of all, let's include header files. I'm including iostream.h and conio.h. Now I'm writing my main function. Inside this main function, let's declare, first of all, let's declare clr scr. This is my clear screen function so that we don't get any garbage value. I'm declaring two variables, int x and y. Fine. Let's ask user to enter values. So we know that we can do this thing with the help of cout. Enter values for x and y. Fine. I'm putting a endl. Now those value I'm going to store at x and y. Fine. Now let's check these value before swapping. So before swapping, I'm checking these number before swapping. So number before swapping, cout. Let's print value of x and value of y. So x is equals to How I can get value of x? By simply writing x like this, right? And I'm doing endl. Similarly, how I will get value for y? On screen I will get y is equals to, and value of y I will get from y variable, correct? Now let's call the function swapping. Now for that thing I have to define a swapping function. So I'm making that function as global. So I'm declaring, or better say I'm doing prototyping for that function here. For creating any function I have to write return type. So let us suppose my return type is void. I want to swap, so I'm writing function name as swapping. I'm giving name for this function as swapping. This swapping function will swap two integer values with the help of reference. So I'm writing int ampersand and one more value which is also of integer type. So int ampersand, and I'm putting a semicolon because I'm not going to give definition here. I will give definition somewhere else. Fine. So this is my function declaration. Now if I want to call this function, I have to write function name and I have to pass parameters. So my function name is swapping. Now be very clear that you should not do mistake in function name. Whatever function name you are using for declaration, same function name you have to use for function calling and function definition also. So I want to swap x and y. Fine. So by doing this, my value will be swapped. As soon as this particular code will encounter, this particular swapping x comma y will be encounter, my compiler will search for definition. Fine. We will write definition also. Before that, after completing my definition, because this function is void, I don't want this function to return anything. So this function will not return anything, it just swap the value. Now let's print those value after swapping. Fine. So after swapping, if I want to print, sorry, uh, number after swapping, right? So we can print this, means now again we have to check value of x and value of y, right? So x is equals to, and I will get value of x and y is equals to, and I will get value of by normal y, right? And I'm putting enter. So this is my main function. I'm closing this main function. Now I'm writing definition for swapping function. So I have to write return type, function name. Function name was swapping. Fine. Now it is taking integer type reference variable. So for reference variable, let us suppose this a is my reference variable, and here let us suppose this b is my reference variable. Now note this, I'm not putting semicolon after this function name. Full function in definition, I'm not putting semicolon at this point. I'm not putting statement terminator here because I want to give definition. I'm opening braces. Fine. Now I'll do swapping by using a third variable temp. So right now temp third variable is empty. Whatever value which is inside a, I'm putting that to temp. So that means value of a is stored safely at temp. Now whatever value inside b, we can override the value of a by using value of b. So value of b went to value become value of a. Fine. Now If I do b is equals to temp, temp is not having anything but value of a. Fine. So if you can see, my values are swapped, and we will write return, or we need not to write anything because it is void. Fine. So by using a third variable, we are swapping the values. First value I'm putting to temporary variable. In this temporary variable, value of first variable is safe. Then we are overwriting the first variable value by second variable value. So now first variable is having second variable values, and then we are putting value of first variable to second variable from this temp variable. Fine. So this is my swapping program, and everything is happening with the help of reference. Now I'm creating this function swap before main function so that this function become global. We know that a global function or a global variable is one which we can use throughout our program, right? So your program execution will start from main function. As soon as your compiler enters in main function, he will create two integer type memory cell. He will allocate the address to x and y. At two addresses, the variable names are x and y. Now we are entering the values, and those values we are storing at x and y. Fine. Now we are printing before swapping value of x and value of y. Then we are calling a function. As soon as we call a function, compiler search for initialization. Compiler will see that it's a global function, plus it is taking reference. It is taking two variables as reference. So this x and y, they are my actual argument. They are my actual parameter. But as soon as this line will encounter, compiler will jump for to the definition. And as you can see, this is outside my main function. So this is my formal argument. This a and this b is my formal argument. Now return type should be same as we declared. Function name should be same as we declared. And as you can see, it is taking two parameters. That means value of x which is coming from that function will be catched by a, or let's say on the same actual copy, a is now alias of x and b is now alias of y. Fine. So whatever value of x is now value of a, and whatever value of y is now value of b. Now using a temporary variable, we are doing the swapping. As soon as this definition finishes, the compiler will jumps to the next line of function call. So here we are printing the number after swapping, and we are printing now x and y which are actually swapped because of this function. So let's save this program. Swap.cpp. Okay, let's check for error. Alt F9. We don't have any error in this program. Let's run this program. Control F9. Okay, so our program is asking for value for x and y. Let us suppose value for x is 10 and value for y is 20. So as you can see, number before swapping is 10 and 20. Number after swapping is value of x become 20 and value of y become 10. So this is how we can use address of operator. Here we are doing changes in the actual copy of data. We are not doing changes in the duplicate copy. Fine. So at last, let's summarize everything. We studied about pointer. Pointer is a variable that holds the address of another variable of same data type. It is very essential. If we are having a pointer of integer type, it can only hold address of an integer type variable. If we are having a pointer of character type, it can only hold address of a character type variable. Fine. For defining a pointer, we have to write data type, then we have to write dereference operator, that is this star, and then we have to give pointer name. So for example, I can write int star ptr. Fine. So the asterisk star tells that the variable pointer name is a pointer variable. Fine. If we normally define a variable, we just write data type and variable name. Only just because of this star, our compiler come to know that it is a pointer variable and it will hold address of some data variable. Fine. So as you can see in this example, we are having a normal variable a. This is name of my location. If I assign int a, so this is a variable of integer type. If I do int a is equals to 10, value for this a is 10. Let us suppose ATF is the address of this a. Fine. So this particular location has a name a, value 10, and memory address as ATF. Pointer name needs a memory location. Pointer name points to a variable of type data type. Means similar type of data type should be there, then only the pointer variable will able to point it. Benefits of pointer. Pointer are more efficient in handling arrays and structures. Pointer allows reference to functions and thereby helps passing to function as argument to other function. It reduces the length and complexity of a program, and it also increases the execution time. It allows C to support dynamic memory management. C programming allow passing pointer to function. To do so, simply we have to declare a function parameter as a pointer type. So all these things are advantages of pointer. Now we are having call by value and call by reference. So first, call by value. In this, duplicate copy of original parameter is passed. Fine. So in call by value, there is a duplicate copy, while in call by reference, like we did swapping, in that swapping we are working on the original parameter also only. We are not making copy of that data. For call by value modification, no effect on original parameter after modifying parameter in function. But in call by reference, original parameter gets affected if value of parameter changed inside the function. Fine. Because we are dealing with original copy in call by reference and duplicate copy in call by value. A function is a group of statements that together perform a task. Every C++ program has at least one function, that is our main function, and all the most trivial program can define additional functions also. We are having two types of function, library function and user defined function. Library functions are those functions which are inbuilt in the system library, like stdioh, iostream.h, conio.h, math.h, string.h, all are library function. User defined function are those functions which we define and and its definition do in the body of the function, it will do some particular task. Fine. Then we studied about function component. For function component, we need function declaration, means function initialization, function definition, and function calling. Uh, for defining a function, for function component, return type should be must. That if there is no return type, we have to write void. Otherwise, on the basis of the value function is going to return, on the basis of that we can define return type. Function, we have to define function name with in bracket we have to write parameter list. Fine. Argument passing, we know two types of argument passings are there, call by value and call by reference. In call by reference, we are working on the actual copy of the data. We are creating the alias, we are passing the data with address of operator. In call by value, we will work with local means copy of a data. We will not work on actual data. Fine. This is it for this session. Thank you very much.